Today we're going to be talking about equilibrium. So we're going to talk about the constants that you can deal with that. So we're just going to look at a basic equation again. So we're just saying that A and B react to form C. So to determine the equilibrium constant for that reaction, it's really simple. You just have K sub C is going to equal, you take the concentration of your products raised to the power of their coefficients and divide that by the concentration of your reactants raised to their power of their coefficients. So for this equation, you'd have concentration of big C raised to the power of little c all over the concentration of big A raised to little a times the concentration of big B raised to little b. And that's that. So if you know this constant already, you can plug that in to determine the concentration of each of your A, B, and C if you use a Rice table. And then if you want to determine how far away you are from your equilibrium, you can use another equation. So you say Q sub C, and it's going to be the exact same as K sub C. The only difference is this time the concentrations that you're putting in for your reaction are the concentrations when you're not at equilibrium. So this one, K sub C is at equilibrium, and Q sub C is not at equilibrium. So we have that. So then, if you already know your K sub C value and you calculate your Q sub C value, you can get a couple different scenarios. Number one is where K sub C equals Q sub C. So in that case, that means that the concentrations you've observed in order to calculate this value are the exact same concentrations that you'll have when this reaction is in equilibrium. You can also get Q sub C is less than K sub C. So that means that you have more products than you have reactants. So you're towards the left side of the reaction. And then the third one is where Q sub C is greater than K sub C. And that would mean that you have a higher concentration of your products than your reactants, so you're towards the right side of the equation. So that's what we're going to cover with equilibrium, and hopefully that all makes sense.